All right, so we're going to review this test a little bit. And let's get started. Okay, here we go. I think we're good with number 1, right? Okay, let's go number 2 then. All right. Well, you're going to have to talk to somebody about that, because if you got that wrong, then you're in the wrong place. Then you just didn't study. I mean, honestly, really. Okay, so I'm going to start with number 2. All right, and what is this? This little bit's 8. This whole thing right here is what you're solving for, which is x. And they tell you this is 12, and this is a right triangle. Okay, so we're in a situation where we're going to use the geometric mean, correct? So what we're going to do is see what relationships we have. Well, this right here is the geometric mean. So we're going to do this. So it's actually the geometric mean, so it goes here and here. A lot of times on the geometric mean problems, it's a variable, isn't it? This time it's not a variable. They actually tell you what the number is. So we're still going to put it in both places. But this altitude is a geometric mean between what and what? Between the two segments of the hypotenuse. So between 8 and this part right here. Is that part right there x? No, it's not x. It's x minus 8. That's right. So you got to make that x minus 8. The whole thing is x. That's 8. So that's the difference between x and 8. Okay? And then you can put the stuff in here. So let's see. What do we got? Between 8 and x minus 8. Got to make sure you do your algebra correctly. You got to distribute. All right? Some people forget to do that. Okay? You got to take that 8, multiply by x minus 8. So it's a distributive property. So it's going to be 8x minus 64 equals 12 times 12 is 144. Add a 64 to this, and you get 8x equals, what's that? 8. That's a 0 and that's a 2. Divide both sides by 8, and I don't know, what is that? 26. All right, and that's what x is, isn't it?
That's the whole thing.
That's the whole thing, right? Because, well, because you solve for x, right? And that whole thing is x. X minus 8 would be this. So that would be what? 18, right? Okay. But they don't ask for that. They ask for x. All right, enough of that. Let's move on. Number 3. Let's not even do number 3. Okay, well, I'm not going to draw the picture for you, but we'll set it up. So x is one of those sides, isn't it? So x is the geometric mean on number 3. So I'm going to put an x here and an x here. But it's between what and what? Not between 3 and 10. If you take one of the legs of those right triangles, it's a geometric mean between the whole hypotenuse, which is what? What's the whole hypotenuse? 13. And the segment of the hypotenuse that's adjacent to that leg, which is 3. So it's 13 and 3. It's not 10 and 3. So you cross multiply, that's easy. 39. Take the square root, and that's your answer. Okay? So you have to know your relationships. Look at number 4. I'm not going to draw the picture again, just for sake of time. I'm not going to do that. So yeah, basically it's just Pythagorean Theorem. Not basically, it is. It's exactly Pythagorean Theorem. Okay, so what do you got? You got 30 squared plus 80 squared equals x squared, because x is the hypotenuse, correct? You plug and chug, and you get, what is that, 7,300, I believe? When you get that, that equals x squared, but then you got to take the square root. You can't leave it like this. Okay, I told you at the very beginning, and I told you all this chapter that I'm going to make you simplify the radicals, didn't I? I said from day 1, I said to simplify the radicals. This is an easy one to simplify. What makes this easy? Jared, what'd you say? Yeah, times 100. 73 times 100 is 7,300. It's got 2 zeros on the end. All right? Don't you feel silly now? All right, so it's 73 times 100. And so let's simplify. What's the square root of 100? It's 10. Can you take the square root of 73? Nope. And that's your answer. It won't come out to an even number, but I mean, you can get a decimal out of it. But anyway, but that's your answer right there. Okay, and I wouldn't accept anything else. Because I told you, because part of doing these problems, I wanted you to learn how to simplify the radicals. And we spent a lot of time talking about how to do that. All right, so I stuck to my guns on that one. It's pretty important that now there is something that I kind of wimped out on. And that's like when it said round to the nearest tenth or the nearest degree. I didn't take off for that. So some of your grades could have been even lower because I didn't take off for that you didn't round correctly, which I legitimately could have marked it wrong, couldn't I? Because the problem says rounded to a certain decimal place. But the grades were so bad, I'm like, I'm not going to, they might as well try to get every problem they can here. All right. Number 5. We're doing 5.
Why no?
Okay, so looks like this, looks like this, looks like this. It's pretty close. All right, let's take a look. They tell you that this is 24, and this is 24, and the bottom is 24. So it's a what kind of triangle? It's an equilateral triangle. So let's do this. Let's just put the thing in here first. Drop this straight down like this. And this is a right angle, and this is x. And that's what we're trying to solve for, correct? So let's see. You could do this a couple ways, I guess, but this is how I would look at this. It's an equilateral triangle, which means it's equiangular, which means what are the angles for all of them? 60. So that's 60, that's 60. This whole thing up here is 60. But if it's perpendicular to this, what does it do to this angle up here? Splits it in half. So that's going to be 30. So it's a 30, 60, 90 triangle, isn't it? All right, and you should know some things about 30, 60, 90 triangles. The reason that we learned all these things is just to make things go a little bit easier. We want to find x. Now, on the 30, 60, 90, x is the long side, isn't it? Because it's opposite the 60. The 24 is the hypotenuse because it's opposite here. There's not a relationship between the hypotenuse and the long side, is there? All the relationships deal with what? The short side. So that's what we want to find before we can find the long side. Everybody with me on that? Now, you could have done this. Now, watch. You could have done Pythagorean Theorem. You could have said, well, it bisects this angle, and it also bisects this opposite side. So this short side right here actually is 12. But it's two ways. It's 12 for two reasons. So 30, 60, 90, it's half of the hypotenuse, isn't it? Or it's half of the bottom because this thing bisects the bottom. You see it? So it's 12 for two really different reasons, but it's still 12. Okay. If these two sides are equal, yes. Okay. If it's a isosceles triangle and this is perpendicular from the top right here, yes, it bisects the angle and it bisects that side. Those are theorems that we talked about quite a long time ago. Okay. So now, once you know the short side, how do you find the long side? Remember this? The long side is equal to what? The square root of 3 times the what? The short side. That's something that you have to have memorized. Okay? There's nothing I can do for you. I mean, I've done enough. I've done everything I could to get you to learn this. There comes a point where you have to learn these relationships. Okay? And if you don't know these relationships before you walked in to take the test, you haven't done enough to prepare. Okay? So this is the long side, so we just take the short side multiplied by square root of 3. So that's easy. It's just what? 12 square root of 3. So the math was pretty simple on this, wasn't it? What was really the only arithmetic? Well, a couple of things. You split this in half, right? You took half of this, you took half of this. That was really the hardest arithmetic in the whole thing, wasn't it? Just taking half of a couple numbers, right? But you got to know those relationships. You have to know this. Again, don't blame anybody else, okay? Except yourself if you walked into the test not knowing this relationship, because I told you needed to know it. All right? Let's do another one. Let's draw this. And this is a square, isn't it? Not just because it looks like it, but because what? Well, why is it? They didn't tell you it's a square. Well, they tell you all four sides are equal. Now, just knowing all four sides are equal is not enough, is it? But knowing a 90-degree angle there, that's enough to tell you it's a square. Everybody with me? Okay. And the length of this is 30, and they ask you to solve for just one of the sides. It doesn't have to be this top one. I mean, all four of them are exactly the same, aren't they? All right, so let's see, what are we going to do? Well, it's a square. These two sides are equal right here, so that means that this angle here and this angle here are equal, aren't they? So what do they have to be? 45 degrees. So it's a 45, 45, 90 triangle, isn't it? Now, I got the x up here, but I could put the x here, couldn't I? It's the same thing. So we have a relationship on a 45, 45, 90 triangle. Do you remember what that is? That the hypotenuse is the square root of 2 times one of the legs. That's the only one you had to learn for 45, 45. All right? But this time they give you the hypotenuse, don't they? And what is the leg? The leg is x. So I plug it into my little formula that I have memorized. Right? Don't you have that memorized? And then you plug it in and you solve for x. How do I solve for x? Divide by the square root of 2. I mean, there's a couple ways you could have done this, but this is probably the best way. Now, do you write your answer like that? Do you put it into a calculator and get some decimal number? No, you don't. That's right. So you go 30 over the square root of 2, and we've done this before, haven't we? Multiply top and bottom by the square root of 2. So you get 30 square root of 2 over square root of 2 times square root of 2 is 2. We don't leave it like that because 2 will simplify. It'll go into 30, which is 15. There's our answer, 15 times the square root of 2. There's probably another approach to this, but I think that's probably the best approach. Well, you could have done Pythagorean Theorem. You could have gone x squared plus x squared equals 30 squared. Couldn't you? Right? Because that's an x and that's an x because all four sides. It's 2x squared. Right. So you get 2x squared equals what? 30 squared, which is what?
No.
Yeah. 1x.
If you're saying x squared plus x squared, you can't put it as 2x squared.
You can't?
Oh,
What's 1 apple plus 1 apple? It's 2 apples. So 1x squared. So 1x squared plus 1x squared is 2x squared. And that's equal to 30 squared, which is 900. You divide it by 2 and you get 450. Then you got to take the square root. I'll let you do that if you want. That right there is the same thing as 15 square root of 2. All right? I'm not going to do that just for the sake of time, but you could do that on your own. All right. Let's keep going. What about this one? This is a parallelogram. Let me kind of make it look like a parallelogram. Let's see. Transform, shear. Let's go about 20. And there we go. All right. And then they draw a line from here. Nope. From here to here. And they make it perpendicular. What else do they tell you? They say AD, which is that top one, which is 14. And they tell you that angle D, which is that top right one, is 60. And they ask you to find AF, which is this diagonal looking one. We'll just call it X. Is that all right? Yes. All right. Everybody with me so far? So this is basically what they tell you. I just didn't put all the letters in there. Well, I got a 90, got a 60, so what's this angle right here? That's got to be 30. So again, it's a 30, 60, 90. What is the x? Is it the short, the long, or the hypotenuse? It's the long side. What do they give me? What is the 14? It's the hypotenuse. What do we need to find? The short. I need to find the short. I can't go directly from the hypotenuse to the long side. I got to go through the short side, okay? So find the short side, which is very easy. If the hypotenuse is 14, what's the short side? It's 7, okay? And now, this is just as easy as well. If I know the short side, what's the long side? It's square root of 3, right? 7 times the square root of 3, and that's it. That's all there is to it. That's the easiest way to do it. I can't imagine a better way to do this. You can't use sine, because if you use the sine, listen, if you use trig functions, you're going to put it into your calculator with the sign of whatever, and you're not going to get an exact answer. You're going to get a decimal. Well, most don't, okay? But most calculators will not give you, listen, most calculators will not give you this exact answer, okay? So the whole idea, and this was so much easier. I didn't have to use a calculator one time on this, all right? High five on that? Okay, yeah, okay. Well, I can't reach that far. Okay, let's do number 8. Let's make it look like, I'm tired of yellow. Let's go to blue. Alright, so let's go here, here, and here. We are on 8. And then you got one right there. Okay, they put a right triangle here, right triangle here. That's X. This is Y. This is 8 square root of 3. And this is 60 degrees. Alrighty. Oh, and this is 30 down here, which I really didn't need to know, did I? Because if that's 60 and that's 90, that had to be 30 to begin with. Alright. So let's see what we want to do here. Can we solve for x right away?
Yes.
I guess we probably could, because look, and if that's 60, that's 90, that's got to be 30, right? So let's see. You could. I think y is pretty easy to solve for right off the bat. Watch this. Because look at the big triangle. It's a 30, 60, 90, isn't it? Okay. In fact, all three of these are 30, 60, 90s, aren't they? All right. So that's this whole big triangle right here is a 30, 60, 90. This is the short side because it's opposite the 30. This is the longer side because it's opposite the 60. So how do I find the long side? I take the short side, 8 squared of 3, and I multiply it by what? Square root of 3. And so this is 8 times what? 3. 8 times 3 is 24. Okay, so that side right there is 24. See, isn't that easy? Now watch this. What's nice about doing it that way is solving for x. Now look at this triangle right here. That medium-sized triangle. Still a 30, 60, 90, isn't it? This is the short side to that medium-sized triangle. That's the short side. This is the what? No, not. It's the hypotenuse because it's opposite the right angle. This is the hypotenuse. That makes it super easy. Just divide it by 2, and x is 12, and there you go. That's the easiest way to do it. There is another option on this, maybe a couple other options on this. To me, yeah. Well, again, if it's 30, 60, 90, stay away from the sine and cosine stuff. Use what you know about 30, 60, 90 triangles. That's why we learn it. Okay? Listen, what if I asked you to do this without a calculator? Then you'd be sunk. You wouldn't be able to do it, would you? Using sine and cosine. Okay? So if I asked you to do it without a calculator, you could do this without a calculator. Right? So you need to be able to learn how to do this. Don't just say, my calculator is good because it gives me the square root answers, so I'll just use the sine and cosine. You're not always going to have that option. You never know. You never know. So learn what I'm trying to teach you. Okay? All right. Now, I'm fine with calculator. I have no problem with calculators, but I want you to know what the calculator is doing, and I want you to know I'm not that concerned. I mean, I am concerned about the answers, obviously, okay? But I'm more concerned about the process. I want you to learn the process that I'm trying to teach you, all right? And I think we get too wrapped up in worrying about what the answers are, even though the answers are important. I'm not saying they're not, but the process to get the answer is what's important. Now you can use your trig function. Everybody wants to use your trig function. Now's the chance. Okay? So look, it's not a special triangle. It's not 30, 60, 90. It's not 45, 45, 90. So now we're going to use our trig functions. And so what do you got? You're going to use this angle right here. I've got this side right here, which is adjacent to this angle, isn't it? And this side right here is the hypotenuse. Which trig function uses adjacent and hypotenuse? The cosine. So I take the cosine of 16 equals the adjacent 8.3 over the hypotenuse, which is x. And then just switch the x and the cosine of 16, right? So x is 8.3 over the cosine of 16. Chuck it in your calculator, and that's your answer. Make sure you're in degrees, yes. Why would you want to?
Yeah,
Look, I had this big talk in my other class about this. Look, it's a right triangle. Don't use law and sine and cosine for right triangles. It's easier. I'm trying to show you the easiest way to do things, okay? If you have 30, 60, 90, 45, 45, 90, use those rules. If you have a right triangle, just use your basic trig functions if you have a right triangle. The only time you want to use sine and cosine, now, will sine and cosine or law sine and cosines work with this? Yeah, it will work, but it's more complicated, all right? Use the trig functions, okay? I'm telling you, I've been there. I've done it. I know what's the best thing to use for these type of problems, okay? So take my word for it. Trust me. Number 10. What? That's his fault, okay? I mean, look, he's a big kid. He knows better. So he won't, he's not getting A's now. So, I mean, he did that one time, but with this new stuff, he's not. So, I mean, you know, if that's what he wants to do, he's a big kid. What's that?
Jeremy told us to wake him up every time we
Oh. Joe! Here,
Joseph!
tap you. Wake up. Pay attention. Alright, this is x. The whole thing is 32. Alright?
The one I have problems with.
Right there. What does what come from?
I did it right.
I put it in the middle. They put it over here. Watch this. They put the 45 feet, and they put a little line here, a little line here, right? And they do this, okay? But it looks a little bit better if we put it in the middle. Isn't that the same exact height? Isn't that the same height? Yeah. All right. So, let's do. It says find the measure of the angle. Okay, so we're just solving for x, and we're putting it in the nearest degree. Correct? We're not rounding it to a decimal. We're keeping it in the nearest degree. So we know a couple things. We've already talked about this. Now you have to make a little bit of an assumption. They say it's an A-frame house. So what do you think is true about this side and this side right here? That they're equal to each other. Okay, it's an A-frame, and A looks like this. Okay, and those two are equal. So that means it bisects this angle right here, and it bisects this side down here. So what is this side? This is 16, correct? And yeah, then that's it. So now what can we do? We can go opposite and adjacent, which is what? The tangent. So the tangent of x degrees is opposite over adjacent. So you put that in your calculator. You got to hit the second function tangent, right? All right, so make sure that you hit the second function tangent of 45 over 16. I don't know what that is. You tell me. What is that? Anybody get it right? What'd you get? Come on, tell me.
I got 69 degrees, but
70.
57.
Right, because it was like 69.4 or something, wasn't it? Okay, so watch. If it's 69.4 and I say round it to the listen, shh. If I say round it to the nearest degree and you write 69.4 degrees, is that rounded to the nearest degree? No. So what is that? Was it 0.4? Somebody do that for me. Is it 0.4?
70.4 when you.
Yeah, it's 70.4. It's not 69.4.
Oh, well, why did somebody say 69?
Colton did.
Because, and once again.
Okay, 70.
I'm sorry.
70.4, okay, if I round it to the nearest degree, will be 70 degrees. All right, and that should be the only acceptable answer I would take right there. But if you put the 0.4, I gave it to you, and I shouldn't have. I was weak. All right.
Okay,
11. 38-foot tree.
I'm surprised I got that.
Cast a shadow. So,
Oh, I did get that.
Did you get it wrong?
I know that's what I think, Caitlin. I got it right too. I was
Easy.
okay, look. 38. That's how tall the tree is. Here's the shadow along the ground. That's 16. Find the angle of elevation. Oh, my word. That's so basic, isn't it? Okay, and find the angle of elevation from the horizontal to the angle, right? Okay, so it's just what? It's opposite over adjacent, so that's tangent again. I'll let you do that, okay? We just did a tangent one, second function tangent to find the angle, and there you go. All right, 38 over 16. It's opposite over adjacent. It's 38. 38 over 16, second function tangent, bang, there's your answer. Okay? All right, next one. A boat is 2,000 meters from the cliff. All right? And it says, how tall is the cliff? All right, so watch. Here's the cliff. The boat's way out here like this. And you're trying to find, you make a right triangle out of it, and you're trying to find out how tall the cliff is, correct? It's 2,000 meters from the cliff. And what else do they tell you? The angle of depression from the top of the cliff is 10 degrees. So is this 10 degrees right there? No, that's not the angle of depression. This, from the horizontal, that's the 10 degrees. So you could find this and make that 80 if you wanted to. The best way, I think, is just to make that 10. Remember, the angle of elevation is equal to the angle of depression. Remember that? Okay, so that's 10 degrees right here. And now, it's pretty basic. So just trig. It's opposite over adjacent, tangent again. So it's the tangent of 10 degrees is equal to the opposite over the adjacent. Multiply both sides by 2,000. Throw it in your calculator. Bang, you're done. Okay? All right. Let's do another one. 13. All right. Plane's flying at an altitude of 10,000 feet. All right. So here's the ground, because it's the altitude to the ground, obviously, isn't it? Okay. And there's 10,000 feet. I don't really care if it's to scale, tell you the truth. That's 10,000 feet. Descending at 60,000 feet from a point on the ground directly below the plane. Okay. So here's a point directly below the plane, okay, and then the end of the runway is right here, so that's 60,000 feet. That, again, is not to scale, but you get the idea. All right, so we make a right triangle out of it, so we do this. And what else do they tell you? They tell you it says the angle of, what do they tell you? Where is it? Find the measure of the angle of depression to the nearest degree. Again, where's the angle of depression? It's this one up here, right? That angle right there. But that's not inside my triangle, so I'm going to find that angle right there. Okay? Tangent. It's like the third time we've done tangent, right? Opposite over adjacent, 10,000 over 60,000. Second function tangent, and that's our second function. It's 1 over 6, right? It reduces, so it's the tangent. You didn't do the second function. Oh. So it's 10,000 over 60. If you don't like all those zeros, look what happens to the zeros. 4 of those zeros cancels with 4 of those. So really, in your calculator, all you got to do is put 1 over 6. Okay? It's not much of a trick. It's canceling out zeros. I learned that back in elementary school. Well, maybe not elementary, but okay. Yes.
So that angle.
This angle.
The same angle as that
That's
angle.
correct.
Are you kidding me?
Why? We talked about that. We had big, long discussions on it. We said that they're alternate interior angles. Remember talking about all that stuff? I've covered all this, haven't I? I didn't give you anything that I haven't covered. There's nothing on here that I have not covered before. Okay? And I told you everything that's going to be on it. And that was so disappointing.
Is it going to be like the same thing?
It'll be pretty close.
It's going to be the same, like none of the weird, like,
All right, that's all time we have. You need to go back and watch some of the old videos or whatever, okay, to figure out how to do this. Is what? It'll be pretty close to this. It'll be pretty close. I haven't looked at the second test. It'll be pretty close.